Hey guys, this is Mr. Sal. We're going to go over the Module 5 reality check. So this is during the pandemic, so hope everyone's good, everyone's safe and healthy, and doing your social distancing or whatever. And if you work in the medical profession, thank you. You guys are awesome. Let's go ahead and get started. If two objects have the same shape, they are called similar. There's a little bit more to it than that, but let's continue. When two figures are similar, the ratios of their corresponding sides are equal. Using this mathematical fact, the height of an object can be found using the length of its shadow, or vice versa. Given a known height of an object and its shadow. So we can see here these two triangles that they're showing. These are two right triangles. So some of you guys may be thinking, well, I'm going to look at the Pythagorean theorem for this. It's not necessary to do that, because if we can set up a proportion like this one, where we're comparing one leg to its corresponding leg and another leg to its corresponding leg, then we get a proportion like this. Now this is just one way to set it up. There are 8 total different ways to set this up though, okay? But just keep this in mind, because the triangles are the same shape, they also have the same ratios, therefore this. So when we're comparing these triangles, there's a couple things that we need to keep in mind when we set up these proportions, okay? Is that the fractions are showing that we're comparing the height, the actual height, to the shadow length. And these are ratios, you guys. So I've got height divided by shadow length on this. And keep in mind, too, that they could be compared in the same thing. I assume it's in feet. So we're comparing feet to feet, but they're lengths of different things, right? And then we compare the two fractions, like this red one right here. This is from the height of the tree, and this is being compared to the height of the person. Now, as ratios, they're the same because, and this is another important key, it's not something we have to remember, but the angles are the same on this, okay? Got a 90-degree angle here. This angle is showing is the same. This is 90 degrees, which means this third angle has to be the same. You don't have to memorize that, but just keep in mind when we're comparing triangles and the side lengths are proportional, the angles have to be exact as well. So they've set it up this way, where we're comparing the tree and the person, these two ratios, which are equal, and then each ratio is comparing the height of a person to the shadow length. Now Damien needs to cut down a tree in his yard and doesn't want the falling tree to hit his house, which is 16 feet from the tree, his fence, 12 feet from the tree, another tree, which is 18 3/4 feet from the tree, nor his neighbor's car, which is 20 feet from the tree. Damien is 5.5 feet tall and casts a shadow that is 3 1/4 foot long. At the same time of day, he measures the tree's shadow and finds it to be 9 3/4 feet long. So we need to use that information to figure out how tall the tree is. Now I'm going to use the same picture up here at the top. Alright, so let's look at some of these values, right? And the first thing we see is that Damien casts a shadow that is 5.5 feet tall. Now if we look at the diagram, that's this value right here, which I'm going to replace with 5.5. And then it says that he casts a shadow that is 3 1/4 feet long, which would have been this value right here. So I'm going to replace that with 3 1/4. I'm only filling in the values of the picture, which will then allow me to replace the values into the proportion, right? For example, the A value was the height of Damien, which is the height of the person, right? Which showed as 5.5. And the B value, the capital B, was the height of, the length of the shadow of the person, which is showing as 3 1/4. Okay, so this is just setting the proportion up. And then we're looking at the tree. So I've got the tree shadow length, which is 9 3/4, which is this lowercase b value. So I know that was my lowercase b, so I can go into this proportion and replace the b with the lowercase b with 9 3/4. So then we have this height of the tree, which is the value we don't know, and in this proportion it's the value that we're solving for, right? So I've got these two fractions that are equal, and I'm going to use the fish method to solve this one. Now, if you want to change these into improper fractions, you could do that. It's not really going to matter which one you use. I'm going to use the improper fractions, but I know some guys have calculators that would be able to use the mixed numbers as is. So I've written those numbers to the right of each of the mixed numbers, just so we can see. And here we go with fish method. And again, I'll be using those improper fractions. So I got 4 values, 1, 2, 3, 4 values. The first 2 values are multiplied, then they're divided, and then that equals what should be the final letter on this one. Okay, so I'm going to start with A, and I'm going to go down. Again, that creates the tail of the fish in this picture, and that first value that I get is the 39/4. And yes, that's in feet, but we'll label the answer anyways. And then I would cross up to this 5.5, which as an improper fraction is 11/2. Then I would swing it back down to the 3 1/4, which is 13/4. And that equals, finally, the A value, which is the height of the tree. So I'm plugging this into the calculator to find the value of A. Now my calculator spit out a decimal, which is 16.5 feet. Of course, you could have had the mixed number, which is 16.5 feet. Or if you really want the improper fraction, that's fine, 33/2 feet. Any one of these three will work. So how tall is the tree? I'm just going to use the mixed number just because they started with them, not that you have to. But 16.5 feet tall. Oh yeah, it did say to write the answer as a mixed number in lowest terms, which we have done right there. So if this tree is 16.5 feet tall, then what are the items that it could possibly fall on, knowing how far away each of the items are from the tree? Well, we just need any values that are less than 16.5 feet, right? That it could possibly fall on. So the first thing that I notice on this is it could fall on, looks like, his house, which is less than 16.5 feet away. It could fall on his fence as well, which is also less than 16.5 feet. It wouldn't fall on the other tree, and it wouldn't fall on Damien's or his neighbor's car, because those are too far away. So it looks like it's just his house and his fence. Alright, this next problem, using the information about Damien's height and shadow from part 1, suppose the tree shadow is 11.5 feet long at the same time of day. How tall is the tree? We'll show our work here, and then we'll round our answer to the nearest tenth of a foot. So this one looks like we may be using some decimals. Now this is the values that we had before, right? But now we're saying that the tree's shadow is 11.5 feet long. So I'm going to replace that 9 3/4 right here. That's the shadow length of the tree. And we're going to replace it with 11.5 feet. Alright, so we got 11.5 feet right here. Now we could use the mixed numbers. Again, I'm going to be looking at the improper fractions instead. And since we used fish method in the last one, I'm going to use cross multiplication on this one. So here's our first cross. Would have A times 3 1/4, which means I would have 13/4 A. And this would equal the other cross, which shows as 23/2 times 11/2. So I've got 13/4 times A, and that's good, but I'm going to put the 23/2 times 11/2 in my calculator. And I get 253/4. Now from here, I don't want 13/4 A, I just want 1A. So I would divide that by itself to make it a 1. 13/4 divided by 13/4. So 253/4 divided by 13/4. Now again, this is something that I can put directly into my calculator. 253/4 divided by 13/4. And what does this give me here? Let's see. Now that's showing is 19.46, and there was a lot of decimals on this one, but it did say it around to the nearest tenth of a foot. So I'm going to take that 19 point, and again the 6 is going to round the 4 up 1 to make that a 5. So 19.5 feet tall would be the height of this tree given these dimensions. Alright, now remember from number 1, this tells us how far everything was from the tree. So if it had those dimensions, now it's 19.5 feet tall. So it's definitely going to fall on the house. It's bigger than the last one. So all the same things that it would fall on, it's still going to fall on, such as the house and the fence. But then we got another tree, which is 18 3/4 feet away from the tree, which is less than 19.5 feet. His neighbor car is, I mean, it's not really great, very safe, but it is safe in this case. So we're not going to overcomplicate this and say, well, it's probably going to fall, you could add an extra 6 inches and be like, well, that's probably not very safe, right? But that's not really what we're looking for in this case. So we'll just write these down. We know that it would fall on his house, the other tree, and it looks like it would fall on, and the fence. There we go. So those are the things that it would still have a possibility of falling on. And of course you may be saying, well, it would have a possibility of falling on the neighbor's car. But again, we're not going to overcomplicate this one. Alright, Damien measures his friend George's shadow and finds it to be 3.75 feet long. George thinks he is 6 feet tall. Is George correct? Why or why not? Well, in order to find out, we'll need to create a proportion. And yes, for those of you wondering, they could compare, or they could just measure George's height and find out for sure, but it's a math class, so we're not going to do it that way. Alright? Now, in the previous couple problems, each fraction was written as an actual height to shadow length comparison. So I'm going to keep it this way, alright? So it says that Damien is 5.5 feet tall, so my first fraction will be Damien's measurements. So we got 5.5 right here. And then we got Damien's shadow at 3.25 feet long. Then we'll compare his friend, who finds his shadow is 3.75 feet long. And yes, we can compare mixed numbers with decimals now. But what we really want is his friend's actual height, which we don't know. So we use cross multiplication on that last one. So on this one I'm going to be using the fish method. Alright, these are the two most common methods for solving proportions like this. So for fish method, I would start at the x, I make the tail. Bam, 3.75, that's my first value. I cross up, and that's my second value in the fish method. Just filling in these values, I swing it back down to 3.25, which is this one, and I end at x. So I can plug these values into my calculator, which will tell me the height of Damien's friend, George. So I got 6.3 feet. And remember that it was asking if George is actually 6 feet. Well, 6.3 feet is not 6 feet. So the answer on this one actually is no. Again, that's because George is not 6 feet tall. He is 6.3 feet tall. So I'll write the answer up here, right? It's no. Alright, for number 4, Damien's favorite ride at Lagoon is Cannibal. It is approximately 208 feet tall. how long would be Cannibal's shadow? And we'll write our answer in feet round to the nearest whole foot for this one. So again, we're comparing actual height to shadow length in these. So again, we got Damien's actual height, which is 5.5 feet tall, and his shadow length, which is 3 1/4 feet tall. And the approximate height of Cannibal is showing at 208 feet tall, so I'll fill this in. That's the actual height. What we want is the shadow length of Cannibal on this one. So let's go ahead and solve this one. Since we did use fish method on the last one, we'll use cross multiplication on this one. So I would cross multiply these two, which would be 5.5 times x. I'll state this while we're doing this one, okay? If you wanted to use the decimals on these, that's fine, right? Like 5.5 is 5.5, and 3 1/4 would be 3.25. You could use the decimals on these, especially since it said to round to the nearest whole. As long as you can do that at the end, then you can use the decimals as needed, or as you want, okay? So in my calculator, I got 3 1/4 times 208, right? I'm sorry, I'll write that out. So 3 1/4 times 208, which my calculator gave me as 676. So now I've got 5.5 times x equals 676. And we're going to figure out the shadow length of this thing. So we're going to divide both sides by 5.5. Just basic solving equation stuff right there. Divide by 5.5. And that gives me x, or 1x, equals 676 divided by 5.5. In my calculator, it gives me 122.90. Looks like that repeats, and you could show it this way. But it did say up here to the round to the nearest whole number, so this 9 is going to add 1 to the 2 and make that 123 foot shadow. Alright, and that completes this reality check. Hopefully that was helpful for you guys. If you got any questions, please let me know, and we'll see you in the next video.